Okay, period 5, here we go. So, if you need help on the homework, the 4.3 homework, you can reference my homework help video that I posted for 4.3. Okay, or maybe at the end of this video, I'll go and do some of the homework problems. So, 4.4, here we go. You need to graph the function f of x equals x squared minus 4. So I guess one good thing about a video is you can pause me and you can skip ahead if you're good on a concept. So feel free to do that. X squared minus 4. So you're going to be graphing a parabola. So this should be a review from chapter 2. Yes, I think from chapter 2. So I'll graph it on here real quick. All right. So let's see. It's a normal parabola, except it's vertically translated down 4. So that means the vertex is going to be, it didn't move left or right at all, so it's 0. And then it's down 4, so 0, negative 4. So that's your vertex. So start out by graphing your vertex. 0, 1, 2, 3, 4. Okay. Then it's a normal parabola, so you can just follow the pattern, the 1, 3, 5 pattern. What that means is you just go up 1 over 1, and obviously you're going to do that on both sides. Whoop. And then it's up 5, sorry, not up 5, up 3, 1, 2, 3, over 1 on both sides, over 1, 1, 2, 3. Or you can substitute points in, it doesn't matter. And then up 5, 1, 2, 3, 4, 5, over 1. Up 5, 1, 2. Okay, and it should be symmetrical on both sides. All right, so there is your graph. And you should connect the lines, which I just am not going to attempt because it won't be straight at all. So graph your parabola. Now you're going to graph g of x, which is the absolute value of f of x. So think back to what we did yesterday. So if you want to, you could make a table. So let's do this. So you're going to have x, f of x, and then you're going to have g of x. Oops. Okay. Let's see, my x values are negative 1, 2, negative 3, negative 2, negative 1, 0, 0, 1, 2, 3. Then f of x, so when x is negative 3, it is 5. So 5 and 0. And when it's negative 1, negative 3. And then negative 3, negative 2. Oh, then when x is 0, negative 4. And then it's symmetrical, so your y values are going to be the same, or you can keep looking at your graph. So negative 3, 0, and 5. Ta-da! Okay, made a table. So then if I take the absolute value of this, what is that going to do? What is going to change? If you take the absolute value, what is going to change? Think about it. Okay. When you take the absolute value, it makes it positive because absolute value is the distance from 0, and distance cannot be negative. I can't run negative 5 miles. Okay, distance is never negative. How far did you run today, Duncan? oh, -2 miles. No, it doesn't work. Okay, so absolute value makes everything positive. So if your y values are positive, they're going to stay the same. 0. Aha, -3. So -3 becomes +3. -4, +4. -3 again, +3. And then 0 and 5. Okay, so it turns everything positive. Before we write the piecewise, oh, so that's what you would write here. Oops. All negative y values turn positive. We're going to graph it, and then we'll add a little bit more onto number 3. So let's graph it. Let me switch over to Desmos. Here we go. Boom. So it's x squared minus 4. And then, so that should be what you got when you graphed it. We're going to do the absolute value. Oh, no. Where's my little... Oh, there it is. So then the absolute value of... No. The absolute value of x squared minus 4. So that is how... That is how it looks as a graph. So this part is exactly the same, and the last part are exactly the same. Here, if we do. So you see where the blue graph is? That's your exponential graph. Sorry, that's your quadratic graph. That's your quadratic graph. This one, and they overlap here, and they overlap here. Okay? So the only part that changes is all of your negative y values reflect over the x-axis and become positive. So all of your negative y values reflect. So let's get rid of this one. So that's what your absolute value graph looks like. All of your negative y values are reflected over the x-axis because they all become positive, because absolute value is positive. Okay? Okay, so we're going to go back. Oh, where is it? Oh, there it is. To here. So all negative y values turn positive. They are reflected over the x-axis. Ta-da. Okay? Reflected over the x-axis, so flipped, which is what happens here. So -3, if you reflect it over the x-axis, it becomes +3. -4 becomes +4. -3 becomes +3, okay? And so on and so forth. Well, actually, that's it. So all of your negatives become positives. So then the piecewise for this, for g of x, so for the absolute value one, the first part of your graph is exactly the same. It's x squared minus 4. Remember, they're overlapping, so the first part of your graph is exactly the same. So the equation for the first part of your graph is x squared minus 4. Okay? We'll come back to the domain in a second. The second part of your graph, that would be this part. So this has 3 sections. This is the first section, and then the middle, and then you have the end section. So 3 sections. So we're going to have 3 functions. So your middle one is the opposite of that. It's the opposite of that. So anticlimactic. There it is. So it's negative x squared minus 4. It is the opposite. So that's the second part. That's because it is the opposite. So if you looked at your table, the second part is right here. So all of them become the opposite. So that's why you put the negative sign. And then the last part of your graph, once again, is exactly the same as the quadratic equation. So you just write x squared minus 4 again. Look at Desmos. This is exactly the same as a quadratic equation. This is where they overlap. So they're exactly the same. They overlapped here and here. So they are exactly the same. So you use that equation. All right. Domains. Domains. Let me pull up the graph. Okay. So here we go. First section. What this point is. Oh, wait for it. There we go. -2, 0. So that's where it switches. So it hits -2 and it switches. It switches from this to this. So it switches at -2. So this one is x is less than -2. You can write equal here if you want. If not, we'll write it in the middle. So you can write the equal either place. Your middle part and then it's less than wherever it switches again. That's the wrong thing. There it is. So the middle part goes from -2, from x equals -2 to 2. So that's the middle part. So it goes from -2 to 2. All right. There you go. Ta-da. Except we have to put, I did not put equal here, so I'm going to put it here. But you can put it either spot, just not both. Okay. Actually, I'm also going to put it here. Oops. Sorry, it got away from me. That's my equal sign. So once again, it can either be equal to -2 here or here, but not both. Okay, and then the last section of your graph, one more time, to Desmos we go. So it hits 2 and it switches again. So it switches at -2 and then it switches back at 2. So this one is going to be x is greater than, what do you think? Think about it. I'll show you the graph again. So this one is x is less than -2. What would this one be? Greater than 2. It's greater than the turnaround point. 2. I keep forgetting. 2. So that would be how you write the piecewise. All right, moving on to the next one. So you have to graph the function f of x equals x plus 1 squared minus 9. Start out by graphing that. So just take a deep breath for a second. You know how to do this. This is a quadratic. This is a quadratic in vertex form. So first thing I want you to do is, what is the vertex? What is the vertex? It's the opposite of what's inside with the x, so it is -1. And then what's the y value? -9. So go ahead and graph your vertex, which it's not on this, which is kind of annoying. So -1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, that's really annoying. 1, 2, 3, 4, 5, 6, 7, 8. Jesus. Okay, so it's like here. 9. There. It goes off the graph, which is obnoxious that they did it that way, but whatever. And then we would go up 1 over 1, so up 1 over 1. So that would be there and there. And then you'd go up over 3, no, over 1, boop, and up 3, 1, 2, 1, 2, 3 over 1. On the other side. Oh, I did that one wrong. Did I do that one wrong? -1, -2, -3. -1, -2, -3. Oh, no, that's right. Never mind. Okay, we're good. And then you'll keep graphing it. Okay. Over 1, up 5 on both sides. I'm going to go ahead and graph it on Desmos because right now it's hard to see. You would have to graph quite a bit more. So let's get rid of these guys. And this is x plus 1 squared minus 9. All right. Oh. Squared minus 9. There we go. So here's our graph. Zero vertex, -1, -9. Okay. So then the next thing we're going to have to do is graph the absolute value of this. So before I graph the absolute value of this, think about what's going to happen. What will happen? How will this change? Think back to the first problem. How will this change? If I graph the absolute value of it, how will this graph change? Okay, here we go. Let's see if you're right. So make sure you put we're putting everything in the absolute value. So x plus 1 squared minus 9, and then absolute value. So once again, everything that was below the x-axis gets reflected, so it becomes positive. Everything that was below the x-axis flips up to become positive. So if we turn this guy off, that would be your graph. Turn it back on so you can see what happens. So on the sides, they're the same. They overlap each other on the sides. This is the same. This is the same. It's the middle that changes. That's where all the negative y values are, all the negative y values, and they get flipped up. Okay. The next thing probably that we have to do is write a piecewise function. Oh, explain what happens graphically. So same thing as before. Oops. All negative y values become positive. Another way to say that, they are reflected over the x-axis. Because absolute value is never negative, because it's distance, and distance is not negative. Okay, write a piecewise function for g of x. Please pause this video and try and do that. Reference the one we just did, but I want you to pause me and try it. Okay, I hope you paused me and tried it for yourself. So, once again, if we look at our graph, how many different functions, oh, let's take this guy off. How many different functions am I going to have for my piecewise? How many sections are there? 3. 1, 2, 3. Okay, so similar to our last one. So, oh, there it is. There. Right, the piecewise function. So the first one is exactly the same as this. They overlap. that first part, they overlap with each other. So your equation is just that equation. So you just copy down the exact equation because they are exactly the same. They overlap. The first section of our piecewise, they overlap with each other on the graph. We'll do domain in a second. The middle part, where they all get flipped, that's the opposite. So it's the opposite of this equation. So negative, make sure you put all of this. So I'm going to use a bracket, and then I have x plus 1 squared minus 9 other bracket. Okay, because you have to take the opposite of this entire equation. So make sure you put either another set of parentheses or you put brackets around the whole thing. And then finally, the last section is exactly the same. So x plus 1 squared minus 9. All right. So those are your three functions. The domain, so when is this true? Let's look at our graph. Here it is. So the first section, when does it change? When does it change? At -4. So it changes at -4. So our first section is less than -4. Or you can put less than or equal to. Personal preference. So this one is x is less than -4. Or you can write less than or equal to. The second part goes between -4 and what else? Let's see. Look at our graph. So the second section, so this part, is between -4 and what's the other point? So where does it change again? Where does it change again? It changed to -4. And it changed to 2. So the middle section goes from -4 to 2. Isn't it fun watching a video of me? Isn't this great? Aren't you having a fun time? I am. Okay, so this one is -4. So it's greater than -4. And I did not write equal up here, so I need to put it down here. I will do that in a second. And then less than 2. Let me add in, wrong thing. Let me add in my equal sign. Boop. And then I'm also going to make it equal to 2. And then the last part is, I'll give you a hint. X is greater than what number? I can show the graph again. So our last section, x is greater than what number? X is greater than 2. This last section, x is greater than 2. Boop. Okay? And once again, you could either write equals to here or here, but not both. So you can write it either place. Number 9, we're going to skip on through. Number 10. So number 10 is a little bit harder. So it says, graph the following absolute value functions and write the corresponding piecewise functions for each. Jeez, mouthful. Sorry, got some ice in there. This one is tricky. Let's look back at number 9. So, oh, did I write it down somewhere? Okay, I'll write it down here. So number 9, everything was inside the absolute value. Actually, I will go back up here. So when we took the absolute value of this whole thing, we took the absolute value of this whole equation and graphed. When we graphed it, we took the absolute value of the whole thing. The whole shebang. Everything was inside the absolute value. When you take the absolute value of f of x, like we did, you have to put the whole thing in the absolute value sign. Okay? Here, there's something outside. Ho, ho, ho. What I want you to do is graph the absolute value of x squared minus 4. So what does that mean? This time they give us the absolute value equation. We don't start out with a quadratic. Please pause me and try these by yourself before I explain them. It'll help you learn. Even if you try it and you get it wrong, it still helps. We learn from our mistakes. So please pause me and try and graph the absolute value of x squared minus 4. Okay, the vertex is, there's nothing inside with the x, so we do not move left or right at all. But we go down 4. So our vertex is 0, negative 4. So that's your vertex. Which, well, I'm trying to think. Yeah. Which, I think it's easier if you haven't graphed these a lot to first graph this as the quadratic. So graph the quadratic x squared minus 4. And then everything that's negative, you're going to reflect up, just like we did in the last two problems. So if you graph this, x squared, if you graph x squared minus 4, then this is your vertex, and then just graph it like we have been, right? And then everything that's below the x-axis is going to get flipped up. So it's going to get reflected. Okay, if you want to start out just graphing this straight away, then your vertex would be 0, positive 4, because it would start out down here. 1, 2, 3, 4. It would start here, right? But if you're graphing the absolute value, this is going to be flipped up. 1, 2, 3, 4. So that would be your new vertex for the absolute value one. Okay, so go ahead and try and graph that, either just graphing it automatically or graphing it as a quadratic and then as an absolute value. So let me do it here. I think, was this the first problem anyway? Was x squared minus 4? Yeah, it was. So this is the first problem we did anyway. So you should already have this graphed. And then if you take the absolute value of that, of x squared minus 4, you got that. Now, you add on the plus 1. Oh, no, we'll do it again. Hold on. I want you to be able to see the difference for the absolute value. Okay. Then we have the plus 1. So before I add it on, what do you think the plus 1 is going to do? So here's our graph, but we have a plus 1 that we need to add on to it. So what's that plus 1 going to do? Think about it. It bumps everything up 1. So all your x values stay the same. Your x values stay the same. It bumps all of your y values up 1. So the vertex was here. Oh my goodness, thank you. 0, 4. It gets bumped up to 0, 5. Okay. This was negative 2, 0. So now it's negative 2, 1. All of your y values get bumped up by 1. So that's what the number on the outside does. So like if this was, I don't know, 8, then your graph goes up by 8. All of your y values go up by 8. So make sure, yeah. So make sure you don't use this. If it's outside the absolute value, do not use it when you're writing your vertex. Your vertex, it starts out at, well, 0, positive 4 because it's absolute value. So it starts out here. And then whatever's on the outside, so it was a 1, it bumps everything up by 1. Okay. Let me go back to here. One last thing. We're going, well, we could go through 11. If for people that need more practice, we'll also go through number 11. If you get it after number 10, you'll be fine. So let's write the piecewise for this. Okay. So once again, we have 3 pieces of our piecewise. So the first one, you replace the absolute value with parentheses. So the first one is x squared minus 4, minus 4, and then plus 1. If you want to reduce that, you can. It would reduce down to actually, let's write it. You could reduce that to x squared minus 3. If you minus 4, yeah. So if you want to reduce it down, you can. Negative 4 plus 1 is negative 3. So either one is fine. So that's the first piece. Oops. So then your second piece is going to be, it's the opposite. So it's going to be the opposite. X squared minus 4. So the only difference here, you're replacing the absolute value with parentheses. Make sure you're writing for this one because there's a negative. You're not taking the negative of you're not taking the opposite of all of it. The 1 is on the outside. The 1 is on the outside. The 1 is on the outside. You're not taking the opposite of it. The 1 is on the outside. Only you're taking the opposite of it. You're taking the opposite of it. Geez, you're taking the opposite of what is inside. There we go. You're taking the opposite of what is inside. Okay, do not let that confuse you on number 9. I'm going to scroll up for a second. Number 9, everything was inside. When we took the absolute value of f of x, that's everything. So everything was inside. So that's why we had to take the opposite of everything. So you're taking the opposite of whatever is inside the absolute value. All right, so there's a difference. So make sure you're writing the 1 on the outside. And then finally, the last piece is the same. If you were to graph this quadratic, it would be the same. I don't know if we did that. I can do that. Oh, no, we did that. That was the first problem. I can do it again. X squared minus 4 plus 1. Once again, you could reduce this down to x squared minus 3. All right, and then domains. Let's look at it. Here it is. Let me take off this one. So the plus 1 doesn't change your domain. The plus 1 does not change your domain. Domain is all about the x values. So your domain is going to be the same as it was. What number was that? That was the first one we did. Oh, it's the same as number 1. No. Yes. So the first one we did, your domain's going to be the same because it's x squared minus 4. This plus 1 doesn't change your domain at all because it does. This only affects the y values, not the x values. So -2. X is less than -2. The middle one, -2. I'm going to do less than or equal to, sorry, greater than or equal to. I'll add the equal sign in a second. And then 2. So the middle part goes from -2 to 2. Domain is all about the x values. Let me draw in my equal signs. Sure, they can be pink, whatever. Okay. And then finally, your last part. X is greater than what? X is greater than what? 2. 2. Oh, no. Greater than 2. There we go. Whew. Okay. I'm going to do 11. So if you want extra practice, I'm not going to do 12. I'm going to do 11. So maybe pause me. If you're feeling like you need extra practice, pause me, try it by yourself, and then I'll go through it. Sorry, I forgot you paused me. I was waiting for everyone to try it. My bad. So you have to write the piecewise, and you have to graph it. So once again, don't panic. You know how to graph this. Okay, start out, what's the vertex? You can either graph it as a quadratic first and then flip the middle part, or you can just graph it immediately as an absolute value. So the vertex here is the opposite of what's inside, so -2, and then it's down 4. So what I would do is if you want to make a table, you make a table. I'm not good at multitasking, so I would probably graph it as a quadratic and then flip it. And then remember, this is going to move you up 3. Okay, so if you're graphing it first as a quadratic, this is your vertex. And then graph it normally as a quadratic. So up 1 over 1, and then up 3 over 1, and then up 5 over 1, and so on and so forth. All right, and then you would flip it, whatever is below. So like right now, your vertex is a good example. It's -2, -2, -4, 1, 2, 3, 4. So right now your vertex is here if you're graphing it as a quadratic. So that would get reflected over the x-axis. So it would be -2, +4, 1, 2, 3, 4. Okay. If you want to do it all at once, let me see if I can do it all at once. No, I can't. I probably can combine 2 of them, but not all 3 at once. So then up 1 over 1, same over here, and then up 3, 1, 2, 3 over 1, over here, and then 1, 2, 3, 4, 5 over 1, and 1, 2, 3, 4, 5. Let me erase my little vertex that I put in the middle there. Boop, 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 boop. Okay, so that would be your graph if you're graphing it as a quadratic. Oh, let me click off it. So then, when you graph it as an absolute value, everything that's below the x-axis is getting flipped, so it gets reflected. Okay? And then after you do that, or if you're doing it all at once because you're amazing, then you're adding 3. I think it's really hard without practice to do it all at once. Hold on, let me graph it. It is the absolute value of x plus 2 minus 4. Then, okay, so that's there. So you get that graphed, and then you add 3. So that means all of your y values are going to move up 3. Okay, so that's what it would end up looking like. Can I copy this? Yeah. And then plus 3. Okay, so everything just gets moved up 3. All right. I shall leave you there.